Welcome to the Six Hats podcast, where I, Dr. Shami, a lifestyle and nutritional medicine family doctor, will talk about how women strive to find balance each day by juggling their six roles, being a woman, mother, daughter, partner, business owner, and professional. Hello everyone, welcome back to the Six Hats podcast, and I'm really excited to have Dr. Max Gulhane join us today. And for those who don't know him, he's got a fantastic podcast which he'll tell us all about, but he's also a fellow GP. He's a doctor from Australia. He graduated from the University of Melbourne, and also he completed a Bachelor of Science from the University of Queensland. So he's been going through the GP training and completing his GP training in Victoria and New South Wales. So welcome, Max.
Hey, thanks for having me. It's good to be here.
So Max, I love how you're talking about light, circadian rhythm, quantum biology. And as an integrative GP, you are so right. This is something that we don't talk about at all. Yes, we've covered nutrients and nutrition and lifestyle, and I talk a lot about stress, but that's something that's been a missing piece of the puzzle. So I love for you to share all your knowledge when it comes to light. Why is it so important? So can we start with the basics? What's blue light? What does it mean?
Yeah, I mean, if we take it all the way back to the beginning, light has been this ever-present input into biology well before humans even evolved current form. I mean, it's going billions of years back to essentially when we were prokaryotic organisms, and the selection pressure or the evolutionary pressure on life was this ever-present source of energy, which is light, and the fact that it changes in its availability on this 24-hour cycle as the essentially rotates around the sun. And that process, I think, more than anything, has influenced life's evolution. And testament to that fact is that organisms as simple as unicellular prokaryotic organisms display molecular processes that recognize and anticipate changes in the light environment. And that is a selectionary and an adaptation process to the radical difference in conditions that exist between night and day. So even before we evolved the gut that we have now, that we use to digest our steak that we're going to eat, and light and its light reception was infinitely older in terms of its evolutionary influence on our bodies. So blue light, which you've just mentioned, is one of the most important wavelengths of natural sunlight that influence health. So everyone who might not have thought about light as too much, essentially the sun emits a wide range of different electromagnetic energy, and that gets filtered by our atmosphere until standing on planet Earth, we get a somewhat narrow range of electromagnetic radiation. So if we start at kind of the shortest wavelength light, the highest energy, we get basically an ultraviolet B they're very high energy photons, and they actually can only penetrate through the ozone layer when the ozone layer is thinner. So say when we're at high altitude or when the sun is directly overhead. And that's why, depending on where you live in the world and what season it is, then that will depend on how much ultraviolet B light actually gets through the atmosphere. So maybe most of your listeners are in Australia. We get UV light pretty much all through the year. In May, around this time, the difference is quite significant. In Darwin, I believe the peak UV index sits around 9 to 10 in May, but then that is all the way down to 1.2 in Hobart. So that's a function of latitude. So where you live in relation to the equator is going to determine how much UV light gets through. But the reason why that's important is because UV light stimulates or catalyzes the conversion of cholesterol in the skin to pre-vitamin D, which then goes through an enzymatic process to give you vitamin D, which is one of these really critical essentially it's a prohormone that becomes a hormone to life. So the reason why I brought UV light up is because that's non-visible, and that's at one end of the spectrum. And then we have UVA, which is very important in things like blood pressure, and it actually helps release these massive stores of nitric oxide, which for your listeners is essentially a very small kind of signaling type molecule that relaxes all our blood vessels. So, people these days, so many people get put on hypertension medication, but how many of them have been told that simply being out in ultraviolet A sunlight is a very potent vasodilator and therefore could be contributing significantly to having a higher blood pressure? So there's a lot more UVA light than UVB that hits Earth, but that's one end of the spectrum, which is not even visible, but incredibly important. So as we move along that color spectrum, we get to blue light, and blue light particularly has a very important role in helping us, and not only us as humans, but other animals actually understand whether it's night and day. And the key kind of circadian biological mechanisms and circadian rhythms are essentially an internal clock that our bodies have that are approximately 24 hours, but not quite. So they need synchronization with external environmental signals, which is most important being light, and particularly blue light. So the recognition of blue light by our eyes and by our skin essentially feeds back into our brain and really tells us whether it's night or day. And as you can imagine, this is very important because the body and other organisms as well have evolved efficiencies that are related to the time of day. So you don't want to be active and as a diurnal mammal, as humans are, so we're active during the day and sleeping during the night. We want to be optimized so that we're alert, have energy, looking about sharp during the day so we can hunt, so we can gather, so we can procreate and do all these things. And yet we want to be resting and recuperating and recovering during the nighttime. So the recognition or the detection of blue light through the eye and the skin too is essentially programming the brain via some special neuronal tracks that connect the eye to the hypothalamus, and then the pituitary gland essentially coordinates that signal. And the interesting thing is that this is not an image forming function of the eye. So I explain it as, the eye has both camera function, and imagine your camera, which is enabling me to see building in front of me, it's enabling me to see the light, the microphone. That's a camera function. That's image forming. And that is essentially done by certain types of photoreceptors in the eye. But what we discovered, I believe it was in the early 80s, was that there's these detector function, and particularly a blue light detector function in the eye too, which is more like a security camera, those lights that flick on and off a motion detector. It analogizes more closely to that, which is it flicks on and off with the detection of blue wavelength light, which is around 480 nanometers, if that means anything to anyone. And the reason why that's so interesting is because the more we learned about circadian biology, the more we realized that humans are essentially a walking blue light detector. And the ancestral evolution or the ancestry of this blue light detecting protein melanopsin is actually in frog skin. So this goes to show this evolutionary path that has been forged is all the way back in amphibians and when we were kind of living in the water. So that is this amazing function of our blue light detecting ability and the expression of melanopsin, this blue light detector in our eyes, in our skin, in our blood vessels, in our fat tissue. It's everywhere. It's in our brain. So what that means for people listening is that if think about the type of light that most people are now living under, and it isn't natural sunlight at all. It is actually artificial light. And what has happened is that we're breaking the dualistic two sides of the coin, which is circadian biology. And that is full spectrum bright sunlight during the day and a complete darkness at night. And you actually need both to have a proper circadian health. But what we've done by moving indoors and creating electricity and electrifying the world, and now even more recently rolling out LED light emitting diode lighting in the name of energy saving, is that we're getting at least 10 to 100x less light during the day and less bright light during the day, and at least that amount more light during the night. So less light that we're supposed to have during the day and way more light at night. And the consequences are devastating because the body needs correct light signals and correct circadian signals to actually program all those functions that I mentioned. And when that doesn't occur, then there's essentially chaos, and there's chaos all the way down at the molecular level because every cell actually has a circadian oscillator in it, and that is programming gene expression, mitochondrial function, etc. So it's catastrophic what's happened today. And the fact is that people are living under this artificial light and they're deprived of full spectrum sunlight. And I didn't go into the rest of the wavelengths, but beyond blue, we have green and then yellow, then all the way out to red and then infrared. And there's actually half of the photons that are hitting the infrared. And that's something the circadian biologists aren't talking about, but is a fundamental and very, very important human need too. So that's the scene, I guess, set the scene for this interview is just, we've got this really deeply ingrained light needs, and that you can think about them as light nutrient needs, and they're being either deprived or completely adulterated in today's modern world.
Amazing explanation. Now, if we had to translate that to daily life, so the average individual, you're spot on, spends most of the time indoors. in artificial light, but also staring at screens, and almost like 10 to 14 hours of screen time sometimes. And we underestimate what that is actually doing. And I want to lead on to the impact on health, because as I explain to patients, it's invisible. It's almost hard to believe what it's doing. And you've explained it really well. We've got the sensors. We've evolved that way, and it's evolved for a reason. And I've got so many patients with different symptoms, and I'm just going to throw a few symptoms out there. For example, the basics of insomnia, difficulty actually getting to sleep. Also, the other side of the spectrum is weight gain, and often people don't even associate the power of blue light and what it does to weight, and diabetes. So it's 3 common symptoms that people know about which we've not associated with blue light, which I love what you're doing on your podcast, just really spreading that information out there. So I'd love for you to chat more about that. How is it actually all connected to weight?
Yeah, that's good questions. So the sleep and wakefulness is most fundamental circadian function, and that is dictated by this hormone it was called the hormone of darkness, but for more complex reasons, it's less so now, but we don't need to go into the details. So essentially, when your body receives blue light, so when you flick on the LED downlight at home after you've come home from a long day, and that light signal is received through the eye, and it essentially ends up at a special gland called the pineal gland, and it turns off the body's production of this hormone called melatonin. And people know about melatonin because they can buy it, in 5 milligram gummies from the pharmacist, but your body makes melatonin itself. And melatonin, again, is one of these ancient molecules, and it was originally an antioxidant before it was a signal of darkness. So people, obviously, there's a role of antioxidants in biology and to quench oxidative stress, which is involved in inflammation, but your body can actually make it yourself in large amounts. And when you turn on that light, and you're essentially telling your body it's daytime, but it's not only, Melbourne winter daytime, it's actually equatorial summer daytime. That is the kind of intensity of the light and the wavelength that you're telling the body is. So just imagine what that is doing to the synchronizing requirements of all those internal clocks when you tell it at 10 p.m. at night that you're confusing it with a midday signal. So that turns off melatonin, and you're not going to be able to sleep because you've just told your body, let's go for a hunt. So, insomnia is the most classic. If you're having trouble sleeping, the first thing you need to do is correct your circadian signals. And that involves obviously seeing the sunrise, because you need natural light in the morning to kickstart this whole process. And actually, the morning sunlight programs the evening melatonin dump, approximately 12 hours later. So you need to get natural sunlight throughout the day. And then when that sun dips below the surface, then the horizon, you need to start putting in place factors or mitigating measures so that you don't send these confusing light signals, and therefore you can preserve your sleep quality. And that gets into the next question, which about weight gain, because sleep quality is fundamentally tied to our metabolic state and our weight. And the expression of these key hormones that relate to our metabolic health exhibit circadian properties. So many of your listeners, you might have been talking to your patients about insulin and insulin resistance. Well, our ability to remain insulin sensitive is going to be a function of the time of day and our circadian biology. So insulin sensitivity goes down during the evening, during the nighttime. And it makes sense, because it's like, why would we be getting ready to digest food if we're supposed to be resting and recovering? And that's because we're not supposed to be eating at nighttime at all. So that's not the only hormone. Leptin, which is it's a hormone of satiety, but it's also a signal to the brain of how much energy is on board. That is secreted in a circadian nature. So the ability your body essentially breaks its fuel gauge mechanism if you're getting these incorrect light signals, and it simply just doesn't know how much energy is on board. So then not only that, there's a paper in, I believe, 2018, and it showed that your body's ability to fat burn through these functions like beta oxidation and other forms of just really critical metabolic functions, they're tied into the circadian mechanism, meaning that if you don't see the sunrise, if you don't get these critical time points in the natural solar day, your ability to burn fat is going to be highly compromised. So it's tied in so many different ways, but you can also think about it this way, is that when natural sunlight hits the skin, and UV light specifically, it actually makes a range of compounds. One of them is alpha MSH, and that compound in the skin induces tanning, but in the brain induces fullness or satiety.
Wow.
And that is a 500 million year old gene that's called pro melanocortin. So this just illustrates how critical light and sunlight is to metabolism and whole body energy regulation, because the cleavage product of the same protein, just in a different tissue, is either it's tanning your skin or it's making you feel full. So obesity, weight gain, it is so fundamental to light. And that is why shift workers are overweight and obese. And I've talked to many people in this space, and Martin Moreed is a MD, PhD, circadian biologist and researcher, and he's worked with big companies and like mines and airports, and they obviously have to do shift work. But the profound effects they see, people just eating overnight, people are gaining weight, the rates of diabetes they're so much higher in shift workers. And the light environment is the fundamental underlying reason why that is the case. And, we can go into different studies. There's studies showing that blue light exposure pushes blood sugar up, and the opposite, which is red light, pushes it down.
Oh, wow. That's really important. I love to also highlight mental health, because often patients say to me, well, I relax by turning Netflix on before I go to bed, or busy mums, they put the kids to bed and finally they've got a bit of time for themselves, so they go on their phone. What kind of message would you send to those listeners?
Yeah. So again, this is how fundamental mental health is to this blue light story, is that melanopsin, that blue light circuit, it takes two essentially roads. One is to this suprachiasmatic nucleus, the master clock, to program the timing. And another one is to an area of the brain called the habenular nucleus. And that is integral in mood and mood regulation. So if you are not getting a morning sunrise and instead you're flicking through Instagram on your blue lit phone, and then at home you're again turning on all the LED power saving downlights and then watching Netflix without any blue blockers or anything else on, then you are essentially destroying or sending incredibly damaging light signals to this part of the brain that's directly involved in mood. So if someone has depression, anxiety, yes, there's lots of kind of levers that we can pull on, and nutrition can be important. Obviously, our psychosocial situation and our stresses is very important. But one thing that no one is really considering is what degree is our light environment causing this depression and anxiety. And, the number of people who find their symptoms improve, their anxiety goes away when they fix this light environment is enormous. A common one is people go on holiday or they go camping for a week or 14 days. And suddenly they're seeing the sunrise. They're not on tech after dark. All those light signals have normalized, and these things go away. It's that integral. And look, there's so many interesting anecdotes in a podcast that I talked about this with, that I mentioned earlier, Martin Moreed. He quoted a study that showed there was a psychiatric hospital and it had certain northern east facing windows that saw the sunrise even through glass, and the south and west facing windows, and it was the same treating doctors, same treating protocols, but the patients who were situated in one of those sunrise facing rooms were discharged at twice. They just discharged twice as quickly, even though everything else remained the same. So it's a very elegantly controlled experiment to show how critical light is to psychiatric conditions, to mental health, to everything that we need to feel mentally well.
I loved how you mentioned about when people go away on holiday and camping, and I actually have so many patients suddenly click and realize actually they did lose some weight when they went camping, or they did feel better, or finally their sleep got better. And it's just correlating with actually what you've done, and it's changing that environment, exactly what you said, which kind of leads on wonderfully to our final question about how can we mitigate blue light in an environment where, you might be working at a desk all day, spending a lot of time indoors. What steps can we take to protect ourselves?
Yeah, so it's a great question. And yeah, it's an amazing observation. People notice that they come home, they've been out on holiday and maybe they've been to Europe and they've eaten, even more on carbs or sugary food than usual, and yet they've still lost weight. And that speaks to the fundamental nature of light and its influence on metabolism. So it can't be overstated. And really, the more UV light you get, the less food you need to eat. That's essentially how it works. And there's other pathways by which the body is able to derive energy from sunlight. But keeping yourself indoors, slip, slop, slapping all the time is going to drive hyperphagia. If you put UV blocking sunglasses on, you're going to block the synthesis of pro-melanocortin, in through the eye and in the brain, and you're going to be more hungry. So exposing ourselves and normalizing our body and exposed to these natural light signals, including UV light, is critical. And that's another whole story about the sun, and maybe we don't have time to go there. But look, to answer your question about what people can do. So this is something that I talk about in my circadian reset course, but really you need to have a framework for thinking about this. And I use a 3 M's framework, and that is, first M is maximize natural daylight signals. So get outside as much as possible without shoes, preferably, and see the sunrise, get in the UVA window when UVA shows up, get a bit of UVB depending on your skin type and your latitude and that UV index that we talked about. And, photosensitizing medications is something that I guess people can talk with you as their doctor. And then see the sunset, get that red and infrared rich sunset in. And if you have to work in an office, just take sun breaks. People used to take smoking breaks, but now we need to take sun breaks. So get out there and sync yourself up to the sun and get that sun in your naked eyes and in your skin. And it can't be filtered through sunglasses or eyeglasses or contact lenses or anything like that. So that's the first M. The second M is minimize artificial light signals. And this is things like, if you have to have artificial light during the day, then use a more warmer light, especially in the early and later in the day. In the nighttime, it means simply turning off lights because your body's expecting darkness. So turn off the overhead LEDs, set up some either warmer red or orange lights, LED lights, closer to the ground. Even something like a Himalayan salt lamp is a step in the right direction. And then finally, the third step is mitigate. And the mitigation, in addition to things like those red lights, is wearing blue light blocking glasses, because what they do is they filter out the light wavelengths that activate melanopsin, that blue light detector. So that can be up to 500 nanometers. So that's why they're so red tinted, those lenses, because they actually have to block the light that is potentially activating that very key, important blue light detecting protein. So that is why people wear the funky red glasses. And that is why if someone's trying to sell you blue blockers that have clear lenses, you're wasting your time, because they're going to be you're still getting melanopic activation, which means you're still turning on your daytime signal if you can perceive the color blue. And you do need blue during the day. That is part of an appropriate circadian rhythm, but as much as possible, make it natural blue from the sun and not any other form of artificial blue. And then covering up under artificial light is important. I mean, we haven't talked about melanoma, and the role of blue wavelength light is highly stimulatory to melanocytes through a couple of different pathways. And you as a GP would have taken off suspicious lesions and maybe diagnosed superficial spreading melanoma in patients where they've never been in the sun. And I bet if you check the vitamin D level, it's going to be either low, deficient, or insufficient, and it's definitely not going to be high. And the paradox, well, it's not really a paradox, but the question is that why someone could develop melanoma with a vitamin D deficiency, and if UV light is causing melanoma. And what we know epidemiologically is that UVB light, chronic UVB light, is less associated with melanoma, and outdoor workers have less melanoma than indoor workers. So that's another can of worms and another puzzle for us. Maybe we can talk about that another time. But there's lots to do, but really syncing yourself up with the sun and avoiding artificial light as much as possible are the kind of key things to do.
I love the fact that I know we can't really go into it, but just not being afraid of the sun. I think so many people are afraid of the sun in so many ways, and for whatever reasons, but I think it's just planting the seed that you don't have to be afraid of the sun, and it's actually there for a reason for your health. We'll have to have you back, Max, to talk about sun and skin cancers and the fear of that, because I think it's very ingrained. But amazing. Thank you so much, Max, for your time today. I think it's going to transform so many lives.
Yeah, you're welcome. I mean, if anyone's interested in learning more about the sun in terms of heart health, I just released a talk from the Regenerate Summit that's on YouTube, a Regenerate YouTube page. And I've got a heap of interviews on these topics on my podcast, the Regenerative Health Podcast. So there's lots for people to dive into if they're interested.
Amazing. I actually tell patients to follow your podcast to learn more, which is awesome.
Thank you.
So Max, before I let you go, where can people find you? We do mention about your podcast as well.
Yeah, so you can find me on my YouTube channel, so Max Gulhane MD, if you type that in, or our Health Summit YouTube page, which is releasing all these lectures and talks from doctors who are focused on lifestyle and focused on lifestyle recommendations by making up their own minds by reading the medical literature and treating patients, and not necessarily just porting, guidelines without nuance. So it's a very interesting group of practitioners who we've got speaking at some of these Regenerate events, and you can watch all those talks on YouTube. And my also on Instagram, Dr. _Max Gulhane, and and the podcast is called Regenerative Health, and you can find it on all the podcast platforms. If people want to meet us and participate in this movement and this kind of community, we've got another event, Regenerate, that's happening in Albury on the 3rd and 4th of August. And there's tickets are on sale at the moment, and it's a great day. This one's actually going to be 2 days. So first day is about food, farming and health, and we've got regenerative farmers talking about reinventing the food system. We've got regenerative farmers talking about the harms of crop desiccation using, glyphosate and other kinds of broadacre herbicides and what impacts that's having on the soil. And we've got all kinds of other doctors speaking at that day. And then on Sunday, we've got a very comprehensive day about light and health. And I'll be speaking in depth about artificial light and health. We've got Cameron Borg speaking about sunlight. We've got Tristan Scott from the US is going to be talking about electromagnetic frequencies and human health. So we've got a whole bunch of very interesting speakers, and there's a big barbecue both days. It's fully catered. It's just a really great event. So if anyone's interested or lives in Melbourne or Sydney and wants to make the journey, it's a great weekend.
Amazing. Thank you so much, Max.
Yeah, thanks for having me. It's been great to talk.
Remember that this is general advice only. Please see your healthcare professional for more information. So what's your take-home message today? Remember, it's all about progress and not perfection. And are you suffering from stress? Visit the Usawa Learning Hub on usawa.com.au for more resources on how to de-stress, re-energize, and reclaim your health. Enjoy the journey.